Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning video brought to you by SQLWorkshops.com. In this video, we will talk about async network I/O wait type. If you are a developer or a database administrator, you would have noticed this async network I/O wait type while you are monitoring server activity. This async network I/O wait type is used when the server is sending network packet to the client. For example, a client sends the query to the server sends the results in terms of network packets. Let's say the client is asking for 1000 rows and server needs 250 network packets to send the rows to the client. The network packet is 8000 bytes if you are using a .NET application, that's the default. So the server will not send all the 250 network packets right away. It will send the first network packet with the first set of rows. The client has to consume these rows and then ask for the next network packet. Meanwhile, the server will wait with a wait type async network I/O. The wait time can be long. There are various reasons this could happen. One is a slow network. Maybe your database server is in the cloud and you are accessing from your data center over the internet, and there is a high network latency. So the client asks for the next network packet, but it takes a while before the request reaches the server and it could send the next network packet, and the server could show a high async network I/O wait time. The other possibility is both of your servers or in your data center, the application server on a different server, the database is on a different server, physical server, and the application is executing a query and the database server is sending the results over the network packet. Here, the application server receives the first network packet. Normally, it should consume all the rows, you should read all the rows in the network packet, then the client API or the client interface will ask the server for the next network packet. There could be a reason that the client is not able to consume all the rows right away. It's not able to read all the rows right away because the CPU usage on the application server is very high. I have seen cases. This could lead to high async network I/O wait time. The other most common reason is the application executes the query, the server sends a network packet, the application doesn't consume all the rows right away, even though there is no CPU pressure. The application reads one row and it does some further processing. It might be connecting to another server or doing some calculation on the row that it already received before it reads the next row and the next row and so on. And this delay could lead to high async network I/O wait time because the server is waiting to send the next network packet, but the client is not asking for it fast enough. Let's look at an example. To practice this example along with me, you need the SQLTest Tool. To download the SQLTest Tool, you can go to SQLTest.org website and click on download. There you can click on install SQLTest. Once you have SQLTest Tool installed, you can click on file, open online examples. There you can click on SQLTest async network I/O example. Once you are here, make sure you are in workload 4 and click Start Current. This will create the database and the table necessary for our hands-on. So here we are creating the database SQL Workshops and we are creating the table tab 72 in the SQL Workshops database. This table has 3 columns. Column 1, column 2 integer, column 1 has primary key defined, and column 3 is a character 2000 column. And we have 2000 rows in this table. The table has been created and we will execute a query based on this table. Here you see in the workload 1, I'm executing the select statement. Select C1, C2, C3 from tab 72 where C1 less than 1000. What SQL Server will do when you execute the query, our row is around 2000 bytes. The network packet is around 8000 bytes. So SQL will package the rows in the network packet and will send one packet at a time. So we will get the first packet, which will have 4 rows. Once we consume the 4 rows, it will send the next network packet. So we will execute this query and we will monitor the wait time of this async network IO wait type. So I will go to settings and comments, and I will copy the monitoring script and I will paste that in the management studio. We will use the stored procedure SPU Pro to look at the wait type and the wait time. If you don't have this stored procedure, you can go to SQLdownload.com and click on download, and there you will find the stored procedure that is related to your SQL Server version. I'm using SQL Server 2014 SP1, so I will click on here to get the SPU Pro version related to my SQL Server version. I will go to a new window, paste it, execute, and I can now execute this one. So now what I will do is go to SQLTest Tool, and here I will start the workload. So this is the query that is going to execute in a loop for 120 seconds. And if you go to workload settings, I execute reader like an application, I execute read, but I don't show the results because showing the results can slow down the query in the result tab. So I disable showing the results, but it will do the execute reader and it will read and read all the rows. So we will start current. It is running this query in a loop. Now we can go to this SPU Pro and press F5. It shows the wait type, async network IO wait type. Wait time is 0. This is very important. The wait time is 0. And if you look at the number of writes the SQL Server writing to the client, look how fast it is. I press F5, 77,000, 83,000, 88,000, 92,000. So it is sending thousands of packets within few seconds. So if you clear the wait stats and you look at the average wait time by executing this query, you will see the average wait time is less than 1 millisecond. That's why we have it 0. So the async network IO wait time is negligible. Now what we will do is we will cancel this query and we will introduce a delay. We will go to workload settings. It's going to execute reader and execute read, right? What we will do is we will put 50 milliseconds delay before it is reading every row. So when it gets the first packet, it will wait 50 milliseconds before reading the first row, 50 milliseconds before reading the second row, 50 milliseconds before reading the third row, and 50 milliseconds before reading the fourth row. So it will be around 200 milliseconds before it reads 4 rows out of the network packet. So we will have the setting, press OK, and we will press F5 or start current. And we will go and monitor this SPU Pro. Press F5. There you see the async network IO wait time is 191, 27. It will go up to 200 because to consume one network packet, we spend around 200 milliseconds because there are 4 rows. The packet is 8,000 bytes. Our rows of 2,000 bytes each. 4 rows, 50 milliseconds per row. So we will be waiting about maximum of 200 milliseconds. And if you look at the rate of the SQL Server writing these network packets, is very slow. Look, 195, 202, 207, 2112. So in a second it's sending around 5 network packets. This is a result of the delay that we introduced. And also, if you clear the wait stats, and if you look at the average wait time, you see it is around 210, 209. This is the average wait time. This shows that async network IO wait time is an issue because the wait time is very high. The one another thing I want to show is this wait time when the SQL Server is sending network packet to the client will not increase beyond 2000. Let's do an example. Let's cancel the query. Let's go to settings and workload settings. Here we will remove the delay. And what I'm going to do is go to settings, general settings. Here I'm going to click on read and enable step at. What this means is the SQL test tool will fire up the query after the server sends the network packet. Before it reads the row, it will wait for me to press a button step. Yeah. So we are making this read manual, but every time we press step, it will read the row. So we click on read and enable step at. We press OK and we press F5 to start. Now you see it waits for step in the database read. So if I click step, it reads one row and then it waits again. If I click step, it will read one row and it will wait again. So if I go to SPView Pro, there you will see SQL Server wait time increases all the way to 2000 and SQL Server will reset to 0 for some reason. It will not exceed the 2000s. And also if you see the packets that are being sent is now fixed because we are not consuming any result from the client. It is fixed at 6. And if you execute this, you will see the average network time to be 432, 440. Because we haven't executed yet. So now I will press step, step, step. We will do a clear and then we will execute. There you will see 2000 because previously some other query reduced this average time. Now you see here SQL is waiting 5 times, 6 times, because every time after it exceeds the 2000 millisecond, it will start the counter again. It will increase the count by 1, so it will never exceed 2000. I want to just give you an idea. If you are monitoring for the average wait time, don't be misguided by this 2000. It means the client pretty much got stuck, and you also see the max wait time is 2000, which means at some point a client was stuck that it took 2 seconds or more than 2 seconds to ask for the next network packet. Let's make a summary. Async network I/O wait time is used by SQL Server when it's waiting to send next network packet. This wait time can be high for a couple of reasons. One is slow network, high network latency. The way to identify is this related to the network or the way the application is processing the data. You could use the SQLTest tool and execute the query that is executed by the application, and you can compare the async network I/O wait time between the SQL test and the application. If there is significant difference, then it is the application the cause for the high async network I/O wait time. Within the application, there could be 2 reasons. One is the CPU usage is very high on the application server, that it is not able to consume all the rows right away. The other reason could be the application is doing row by row processing. The best way to avoid this is, if you are a developer, you should read the rows, cache it in the application server, and process row by row if that is necessary. Thanks for watching. If you have any suggestions or inputs, feel free to send me an email. Bye.